Our ancient relatives, the Neanderthals, lived a very difficult life. They inhabited Eurasia for hundreds of thousands of years, facing harsh Ice Age climates and competing for resources. Their world was filled with daily dangers, from hunting enormous animals like mammoths to surviving the unforgiving cold. But beyond these visible struggles, Neanderthals also fought an invisible war against microscopic enemies, viruses and bacteria. For a long time, we knew very little about the specific illnesses that affected them. We could see healed fractures on their bones, but the story of their internal health remained a deep mystery. Scientists wondered what kinds of sicknesses they endured, and if those diseases were similar to the ones we experience today. To uncover this hidden history, paleogeneticists have developed incredible methods to look back in time. They don't need to find preserved viruses themselves, which is nearly impossible after tens of thousands of years. Instead, they carefully extract ancient DNA from the fossilized bones and teeth of Neanderthals. This genetic material is often broken into countless tiny fragments, like a book shredded into millions of pieces. For many years, scientists would discard the DNA fragments that did not match the Neanderthal genome, thinking they were just contamination. But a groundbreaking realization changed everything. Some of these discarded fragments were not modern contamination, but were actually the genetic fingerprints of ancient pathogens. Using powerful computers and advanced bioinformatics techniques, researchers can now piece together these tiny viral DNA fragments. They compare them to the genomes of modern viruses to identify what they are. This process is like solving a massive ancient puzzle. By reconstructing the genetic codes of these pathogens, scientists can determine which specific viruses infected a Neanderthal individual thousands of years ago. A recent study from 2024, for example, analyzed the remains of Neanderthals found in Chagyrskaya cave in Siberia. This work has opened a new window into the daily health struggles and the specific diseases that plagued our closest extinct relatives, offering a direct look at their prehistoric battle with illness. This new field of paleovirology allows us to build a medical profile for individuals who lived and died over 50,000 years ago. It moves beyond just understanding their bones and tools, giving us a more complete and personal picture of their existence. It reveals that Neanderthals were not just hunters and survivors, but also patients, suffering from familiar ailments that we still confront in the modern world. The evidence locked within their DNA tells a story of coughing, fevers, and sores. This information helps us understand not only their lives, but also the ancient origins of the diseases that continue to challenge humanity today, connecting our health directly to the distant past. The remains discovered in Chagyrskaya cave in Siberia have provided some of the most detailed evidence of Neanderthal diseases to date. Researchers focused on a small, closely related family group that lived around 50,000 years ago. By analyzing the fragmented DNA from these individuals, scientists made a remarkable discovery. They found the ancient genetic signatures of 3 different types of viruses that are still common today. These findings, published in the journal Viruses in 2024, represent the oldest viral infections ever documented in humans. It proves that Neanderthals were infected with pathogens that would be very familiar to us, demonstrating a long history of human interaction with these microscopic invaders. One of the viruses identified was adenovirus. In modern humans, adenoviruses are a frequent cause of the common cold. They lead to symptoms like a sore throat, coughing, and respiratory infections. Finding its DNA in Neanderthal remains suggests they too likely suffered from similar cold-like illnesses. Another virus they found was from the herpes virus family, which includes the virus that causes cold sores, herpes simplex, and the Epstein-Barr virus, which can cause mononucleosis. This means a Neanderthal could have been troubled by painful skin lesions or felt tired and sick from a persistent viral infection, much like people do today. These discoveries paint a vivid picture of their daily discomforts. The third type of virus found was papillomavirus, which is known today as HPV. While many strains are harmless, some can cause warts and have more serious long-term health consequences. The presence of all three of these pathogens offers a glimpse into the chronic health issues a Neanderthal might have faced. One individual in particular, a male named Chagyrskaya D, tested positive for all three virus families. It is possible he felt persistently unwell, perhaps dealing with a recurring sore throat from the adenovirus, uncomfortable skin sores from the herpes virus, and other issues from the papillomavirus. For a hunter-gatherer, being sick would have made survival much more difficult. What this tells us is that Neanderthals were not just fighting the cold and saber-toothed cats. They were also battling a host of infectious diseases. Being sick would have weakened them, making it harder to hunt, gather food, and care for their families. The fact that the Chagyrskaya cave group may have died around the same time suggests they were already under great stress, possibly from starvation. A chronic or acute viral illness could have easily pushed an already struggling population over the edge. This research brings their humanity into sharp focus, showing us they suffered from the same kinds of everyday illnesses that we still manage with modern medicine. The story of disease becomes even more interesting when another human species enters the picture: Homo sapiens. Our direct ancestors evolved in tropical Africa, a region teeming with a dense variety of pathogens and animal-borne diseases, or zoonoses. Over hundreds of thousands of years, this constant exposure helped Homo sapiens develop a more robust and reactive immune system. Their bodies learned to fight off a wider range of infections. Neanderthals, on the other hand, had spent their evolutionary history in the colder, less pathogen-dense environments of Eurasia. While their immune systems were adapted to local diseases, they were likely less prepared for foreign invaders from a different continent. Around 50,000 years ago, waves of modern humans began migrating out of Africa and into the Middle East and Europe, territories long occupied by Neanderthals. When these two groups met, they did not just exchange tools and territory, they also exchanged germs. This was a pivotal moment in human history. The modern humans carried with them the African pathogens their immune systems had adapted to. To the Neanderthals, these were completely new diseases. Their immune systems had never encountered these specific viruses and bacteria before, leaving them highly vulnerable to infection. This phenomenon is similar to what has happened more recently in history when European explorers introduced diseases to the Americas. This pathogen exchange is now considered a significant hypothesis for why Neanderthal populations may have declined. The introduction of new and deadly diseases from Africa could have swept through Neanderthal communities, causing widespread sickness and death. A population already stressed by climate change and competition for resources would have been especially susceptible. Even if the diseases were not immediately fatal, chronic illness could have reduced their ability to hunt and reproduce, contributing to a slow decline over generations. The immunologically naive Neanderthals may have been at a major disadvantage in this prehistoric collision of worlds, tipping the scales in favor of the newly arrived modern humans. The encounter was not a one-way street, however. Neanderthals also harbored their own local Eurasian pathogens, which would have been new to the Homo sapiens arriving from Africa. While modern human immune systems were generally stronger, they still would have been challenged by these unfamiliar diseases. This exchange of germs created a new and dangerous disease landscape for both groups. The ultimate outcome, however, seems to have favored modern humans. Their greater genetic diversity and more battle-tested immune systems may have given them the edge they needed to survive and thrive, while the Neanderthals, our closest evolutionary cousins, eventually faded into extinction. The interactions between Neanderthals and Homo sapiens were not solely about conflict and disease. They also involved interbreeding. Genetic evidence shows that between 47,000 and 40,000 years ago, these two groups mixed, resulting in a flow of genes that persists in most modern humans outside of Africa today. This ancient gene exchange had profound and lasting consequences for human health. As modern humans adapted to the new environments of Eurasia, they picked up some useful genetic tools from the Neanderthals, who had lived there for millennia. Some of the most beneficial genes they acquired were related to the immune system. Neanderthals had spent ages adapting to local Eurasian viruses. By interbreeding, modern humans essentially took a shortcut in their own adaptation. They inherited Neanderthal gene variants that helped them fight off specific types of RNA viruses, a category that today includes influenza, HIV, and coronaviruses. These genes code for proteins that interact with these viruses, helping the body's immune system to recognize and manage the infections more effectively. It is a remarkable example of how ancient encounters provided our ancestors with a crucial survival advantage. The genetic legacy of the Neanderthals became a permanent part of our own human story, arming us with defenses against diseases that we still face in the 21st century. However, the Neanderthal genetic legacy is complex and not entirely positive. For instance, some Neanderthal DNA inherited by modern humans has been linked to an increased risk for certain autoimmune diseases, where the immune system mistakenly attacks the body's own tissues. Furthermore, studies have shown that differences in Neanderthal ancestry can influence immune responses among modern populations. For example, people of African descent, who have very little to no Neanderthal DNA, tend to have a stronger inflammatory response to infections. While this can be good for fighting off pathogens, it can also increase susceptibility to inflammatory and autoimmune conditions, showing the complex trade-offs involved in our genetic inheritance. Understanding this deep history is incredibly important for modern medicine. By studying the ancient battle between our relatives and viruses, we learn about the evolutionary origins of our own immune systems. We can see how our bodies have been shaped by ancient diseases and historic migrations. This knowledge helps explain why different populations today may have different susceptibilities to certain illnesses and why some diseases persist. The story of Neanderthal health is not just a tale from the distant past. It is a fundamental part of our own biology. It reminds us that to understand human health today, we must also look back at the prehistoric struggles that made us who we are.